Sometimes the primary constructor isn't going to be enough. Just like when you define a normal class, you may want some flexibility. One way of looking at the primary constructor is that it's the least amount of information needed to create an instance of the record. It doesn't mean that it's not allowing you to provide additional information or functionality. Just like a class, you can create a body for the record. This will allow you to add fields, properties, and methods, just like you'd do in a normal class. This makes total sense, because under the hood, the record is a generated class. Instead of ending the definition of the record with a semicolon, we are going to define a body for the record. We can add an expression-bodied member that uses the two properties defined by the primary constructor. This can be used to concatenate multiple values or perform computation on those values. Let's say that we have a record that represents a customer, where the first name and last name are two different properties. We might have an expression-bodied member that returns the full name. The customer can also have an optionally defined address. Therefore, it wouldn't make sense to add this to the primary constructor. Instead, we can add a property that holds the address. This could, of course, be using a record that defines what an address needs to contain. If this auto property has a getter and a setter, that would mean this property is not immutable. The only immutable parts of the record are those that are a part of the primary constructor. How would we go by making this auto property immutable? That is, only being able to set this to a value when we create an instance. There is a keyword called init that does exactly this. The init keyword works with properties on normal classes as well. They're not limited to records. If you change set to init, this auto property is now immutable. It didn't add a new constructor or change the current one. How do you then set a value on this optional property? The beauty of using init is that you can initialize the value using an object initializer. Using the target type new expression, you do not have to explicitly declare the type that you are creating. The compiler will infer that this is an address, and you can pass the necessary values to the primary constructor defined by the address record. If you try to change this init-only property after the object has been initialized, you will get a compiler error. This is now immutable, and the value can only be set in the initialization or when using the with expression to get a new instance. Because both the customer and the address are records, you'd get value-based equality out of the box. This means if you compare two customers, which will in its turn compare the address, the values will be used in the comparison. The address will also be a part of this value-based equality, because when the compiler sees that an auto property is used, it will also compare its backing field in the equality check. You're not limited to adding properties or expression-bodied members. You can, of course, introduce your own methods as well. Remember, though, that records should be used to represent data, and when you need value-based equality. If you find yourself in the need for other types of methods that don't just represent your record's data in a different manner, in most cases, you should then have used a class instead. Most of the time, it will suffice to use the primary constructor. But now you've seen how to introduce a non-immutable as well as an immutable property that uses the init keyword. While the customer and address are great additions in the warehouse management system, I believe we have classes in the application that are suitable to become records. Next, we'll be converting some of the classes that are better suited to be records.